In this module, I'll be talking about measurement system analysis as part of a Lean Six Sigma improvement project. At the end of this module, you'll be able to describe the measurement system variability impact to a response, identify sources for data integrity issues, quantify the impact of data rounding errors, differentiate between accuracy and precision, describe sources of variability in response, and then also look into one of the techniques as part of a measurement system analysis is gauge repeatability and reproducibility study. Where does measurement system analysis fit into an overall roadmap is shown in this slide here. One of the things I've noticed over the years is people will say, well, we need to fix our measurement system before we really start our project. I would prefer to go in and look at from a 30,000-foot level point of view of how we're actually performing, given that our measurement system is not necessarily very good. Then measurement system improvements could be an impact and maybe a major impact to the execution of our project. So that's the way I prefer to look at it. So what do we have as the details if we drill down on the measurement system analysis? Well, you can see some of the steps that I think is important to consider, some of which we've talked about on the earlier slide. So again, I like to start with a 30,000-foot level point of view, and this is what I've shown in the upper portion of this slide, is we have a certain amount of variability from our process. If we turn that probability density function on its side, then we get a distribution. We may have an upper and lower spec, but what we basically have, if we got a measurement system issue, we've got an addition to the distribution and uncertainty that we have, and that's shown as the black in that overall picture. So measurement system analysis tools provide us an insight to the magnitude of that uncertainty because of the tools that we're using to measure our particular process. Data integrity is very important. Obviously, we'd say is garbage in is garbage out. So what you really want to do is make sure that your data entry errors are corrected, you've addressed rounding issues, everybody's doing the same thing, and how you're actually capturing the data so that if you got various locations and they're capturing the same kind of information, want to make sure that everybody's doing it the same way. So, and just because it's automatically collected, it doesn't mean it's right. So you really want to make sure that we have good data integrity in our processes. Rounding errors can be a big deal because then that adds to a certain level of uncertainty, and I talk about that in volume 3 in the figure 15.15. It shows a graphic of what that implication is. A lot of times if it's less than 20%, the error is less than 20% of the type of measurement that you're looking at, we'll say, well, it's satisfactory, although that's still not as good as we like it to be. But rounding errors can be a real culprit in the uncertainty of our measurements that we have as an output. We have basically accuracy and precision. So accuracy is dealing with how well we're actually hitting the target on the average, and then precision, it lacks accuracy, but precise is shown in the upper corner. So precise is saying we're hitting the target real well, but accuracy is showing the variability here. The top right-hand one is accuracy, so it's on the average hitting the bullseye, but we have a lot of variability, so it's lacking precision. So the one on the lower left is saying we're just not doing very well either in accuracy or precision, but the one in the lower right-hand corner says we're doing accuracy and precision. So basically, when we take a tool in to get it calibrated, what we're really doing is trying to address the precise issue. Okay. So, no, I'm talking about, I said that wrong. So what we're really trying to do is stress the accuracy issue. So we're trying to get it so the average value is the center. So it's kind of in the upper right-hand corner. We could have a very accurate gauge because of our calibration, but it just does not have the precision. It's got a lot of spread to it. So the gauge R&R addresses the variability that we have within the overall measurement. So if we go in and look at the variability of our overall process, which is shown in the upper right-hand corner, it's basically got two different components too. It's got the true measurements and the measurement error. So the total measurement is the variance that you have, and that's dealing with the process variance plus the measurement variance. So if we're looking at gauge R&R, or gauge repeatability and reproducibility, is looking at the percentage of measurement variation or the precision in a measurement relative to the tolerance, or you could have natural process variability. So you have different ways of reporting it out, and that's in the gauge R&R. Repeatability and reproducibility is shown in the lower left-hand corner. Repeatability is saying, does an operator or an inspector get the same value if they were inspecting the same part again? The reproducibility would be the different inspectors get the same value relative to measuring the same part. So when we're doing a gauge R&R, there's different types of outputs that we can have, and we want to use these to make a decision on whether our gauge is good enough for making inspections. So this table talks about the advantages of some of them, each of them, and also the disadvantages associated with it. So in summary, we talked about the measurement system variability on the response and how it can really be a major impact. We talked about data integrity, also about the quantification of the impact of rounding errors, difference between accuracy and precision, where's the source of variability, and also the outputs of a gauge R&R study.